Hello and welcome to another Zozin session. How about that? Bet you didn't expect that shit to happen. So today is Friday, if I'm not mistaken. I think today is Friday. And I want to kind of get back to a stable schedule where I have like a well-defined projects on the well-defined days of the week. So on a Friday, we usually do a random one-off stream. And that's precisely what I want you to do today. I want you to do something random and one time, right? So I've been programming in pure C for quite some time already, and it's actually kind of freaking boring to use the same language all the time. Even though there's not that many replacement languages for C, unfortunately. A lot of people claim that they managed to come up with the killer of C, and people were claiming that over the past of several decades, right? So people were trying to kill C since 80s, I suppose. Still can't do that. Well, like, unfortunately, I wish we could finally get rid of that stupid language, but unfortunately nobody can finally kill C. So the language of today is Nim. I programmed in that language a long time ago, actually, when I was developing the Boomer. For those who doesn't know, Boomer is this thing that can zoom in and zoom out. It is written, in fact, in Nim programming language. So maybe I'm gonna actually give the links to all of that stuff in the description for lovely people who's watching me on YouTube. And of course, if you're brave enough to watch me on Twitch, I'm gonna give the link in the chat as well, just for you, for the brave people at Twitch, who's not afraid to look at Zozin live. By the way, hello, brave people. Hello, Freefu, Duke, Anulagor, Rastafarian, Mr. Botka, Tsoding. Hello, everyone who I can see in the chat. Welcome. Nim programming. Maybe I want to disable the white spaces. Nim programming language. There we go. So here's the Nim programming language, and the source code of this thing that can zoom in and zoom out. It's available on the Tsoding organization, believe it or not. It's called Boomer. And the reason why it's called Boomer is because it's a Zoomer application for Linux. That's right. So let's put it here, Boomer application. And I'm gonna put it in here. And of course, for brave people at Twitch, here it is. Here is the thing that you can download. So what version of Nim I even use? I don't really know. So let me see. Oh, you're supposed to do it like that. Active boot switch derelease something. I'm not sure if it fails with anything. Yeah, so it apparently doesn't really care. It's a really strange flag, but yeah. So the version is 1.04, compiled at 2019, 2 years ago. I have a 2 years old version of Nim for Linux AMD 64. So where is it installed, by the way? Is it installed somewhere here? I think this is where it's installed. So maybe the time has come to upgrade my Nim. So because the latest version is apparently 1.4.8. Right, I think the time has freaking come. Python, Ada, Modular, some other shit. Anyway, so let's install Nim. So what operating system do we use? Do we use Windows or do we use Unix? I think we're using Unix. Pre-built binaries for Linux. Okay, so we're using x86-64 if I'm not mistaken. So let's download this thing. That is it, apparently. Okay, that was fast, not gonna lie. So, and I wonder, like, it is installed in OPT. Do I keep all of my archives in OPT? I think I do. I saw Nim. Yeah, apparently. Oh, I do. Apparently, I do have a more or less latest version. It's just like, yeah, my config is not redirected to it. But I mean, I think it makes sense to actually use the latest version. Right, so let's quickly do that. To do that, I probably have to go into the root. Right, so let's quickly do that. You know what, I think this is how I'm going to be doing that. Right, so now I'm root. Look at that, I'm using a root console on the machine from which I'm streaming right now. This is the content you all subscribed for. Look at that. I'm also streaming from this machine and I have the root access. Post anything in the chat, I'm gonna copy paste it into this command prompt. I'm joking, I'm not gonna do that. So, okay, let's actually go ahead and take this entire thing and I'm gonna wget this thing in here. There we go. We're downloading and I'm gonna just do tar fvx nim boom. There we go. So it's unpacking stuff. And now I'm actually exiting the root console. I'm actually exiting the root console. Okay, good. So now I'm gonna go to my bash. Let me actually double check if my bash does not contain anything sensitive. I don't think it does, but I'm gonna modify it outside of the screen anyway, just in case. You know, just in case, just in case. Alright, so then I need to restart my console. So now if I take a look at the version of NIM, now we have the latest and greatest version of a NIM compiler that was built in 2021. Recently. Recently, pretty recently. Okay. So Team Ukes. All right, so let's take a look at this stuff. So let's do. How should I call my project? I don't know. So I'm gonna call it Wang tiles, right? So this is gonna be Wang tiles, and let's actually test, you know, the new installation of NIM compiler. New installation of the NIM compiler. So I think I also probably want to update my NIM mode in Emacs because maybe they will introduce like new stuff in there. Right. So I think it's something like proc. And I do remember that the entry point in NIM is something like when is main module, right? When is main module, and this is where you put all of your hello worlds and stuff like that. Right, so let's also remove white spaces. And if I run NIM, and I think I have to do something like C, will that work? Will that work? I think it worked, and here is the executable. Look at that. It's a beautiful, beautiful executable. So, and the executable is dynamically linked. Unfortunately, it doesn't produce statically linked executables. So let's take a look at what it depends on. It only depends on libc and DL and nothing more than that. So that's fine. So, and now we can just run this executable. And here is a hello world. Here is a hello world. It's also pretty lean, by the way. Yeah, because I think C, a compiler produces bigger executables. I don't know, maybe this. So, yeah, I wanted to actually maybe update the NIM mode. Where is the NIM mode? How do you update things? I don't remember. Oh my god, it's so slow because it's you know, downloading the list of packages, and there's too many packages. There's 5,393 packages in Emacs repositories. That's a lot of packages. Well, it's not actually, it's just like Emacs is slow. All of the applications in 2021 are slow because people don't realize that 5,000 things is not that big of a number. But anyway. NIM mode, it's installed. Does it require any updates? How can we know if it requires any updates? I think to update everything you have to press Shift U, and it's sort of marks everything that needs to be updated. And if I take a look at NIM mode, funny enough, NIM mode was never updated recently. Nobody programs in NIM on Emacs apparently. This is actually really interesting. Nobody fucking uses this shit. I mean, I do understand that. I don't program on NIM usually either, so I think it's only fair. NIM mode, yeah, so the latest version was in 2019. precisely the version of Nim I was using, by the way, precisely, and it doesn't even build, and yeah, it's just like nobody's fucking using this shit anymore, unfortunately. It is in fact dead. It is in fact dead. Imagine programming in this language with this support. Yikes. Yikes, 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 yikes. Anyway, so we're gonna be using old ass Nim mode for Emacs. Alright, so what the fuck is Wang tiles? You're probably asking, my friends. Right, what the fuck is Wang tiles? Let's actually Google it up. Wang tiles. Wang tiles, first proposed by mathematician, logician, and philosopher Wang in the class formal system. Okay, so let's take a look at something better. I think somewhere here it is explained a little bit better. The idea of Wang tiles is extremely simple. Right, so the simple case of Wang tiles is basically you have square tiles, right? You have square tiles with 4 sides, right? You have 4 sides. And you are not allowed to rotate these tiles, right? So you have to place them as they are. There's no reason to rotate them. And in a simple case, in a very simple case, on each side, you have 2 colors. Each side can be either one color, in this particular case it is, as you can see, blue, or it could be yellow, right? Blue or yellow. You can actually make it more complicated. You can add more colors. You can, instead of sides, you can use corners, but the idea is going to be pretty much the same, right? So, and how can you place the tiles? You can only place the tiles with the corresponding sides matching, with the color, right? And here is an interesting thing. You have 4 sides and 2 colors. Right, so 4 sides and 2 colors. So that means you can encode a single tile like this, with 4 bits. 0 representing first color, 1 representing second color, right? So we have 4 bits of information. Each individual tile is 4 bits of information. So if you basically cover all of the possible combination of bits, you're gonna have 16 tiles. Right, you're gonna have 16 tiles, and 16 tiles in this specific configuration. In the configuration of using sides and having 2 colors, this is gonna be called a full set of Wang tiles. As far as I know, it's a full set. So, and you know what's cool about it? Is that if you have a full set of Wang tiles, right? And for instance, you have a tile that you want to place in, right? You have a cell into which you want to place a thing, and you already have 4 neighboring tiles. You already have 4 neighboring tiles like this, and these 4 neighboring tiles, they're already placed, and they're completely random. So on this side you have 0 color, on this side you have 1 color, maybe another 1 and another 0. So if you have a full set of Wang tiles, no matter what kind of tiles you place in here, you will always have a tile to place in here, because you have a full set, because you have all of the possible combinations of 0s and 1s. Right, you can always place, like, you can always find the tile that matches in here. Right, you have 16 of them, which makes it super easy to generate random patterns. Right, you have a grid, you start with a random tile. Then, knowing the neighboring colors in here, you can match another tile in here. Right, you can put another tile in here which consists of something like this, and then you can put another tile in here that matches in here, and that limits how many tiles you can place in here, but you can always place a new tile in here, and you can basically randomly procedurally generate different patterns. Neighboring edges must be equal, right? Yes, I precisely mentioned that at the beginning of the explanation. It's a part of the definition of Wang tiles. And if you have this specific set of Wang tiles, you can generate patterns like this. So number here, as far as I know, it just represents the number of like the bits, right? The bit number, the bit mask. And what's interesting is that you're not, color is more of a metaphorical thing. It does not necessarily have to be a color. You can draw them so they form some sort of tubes, or they form some sort of labyrinths and stuff like that. There's a lot of examples in this particular website, so let's actually click around. I think it's a Wang 3E. Right, so there's a lot of different, I wonder if there's, where is the, there was a, yeah, so you can have tiles that looks like this. Right, that generate roads and stuff like that. Right, so but the tiles obey the law of matching with other tiles, and you have like a full set of them. Right, so, and as far as I know, on this website, they had, yeah, they had a generator for different things. For instance, this one is not really that interesting. I think block 4 is the most interesting one. Yeah, so you can generate patterns like this. Right, or you can generate something like that. So yeah, and all of that is generated with Wang tiles, right? So, but you need to have a predefined set of Wang tiles to actually match all of that. So there's a lot of interesting things in here. Yep. So, and as far as I know, this idea is used quite heavily in game development for procedural generation of levels. Right, and again, you not necessarily have to have only 2 colors. You can have 3 of them. Right, but in that case, instead of having like a binary system where you have 000, 0001, 0010, and so on and so forth, right, you're gonna have a ternary system, right? So this stuff is gonna go from 0, 0001, 0002, and so on and so forth. You can still represent all of that with bit masks if you allocate enough bits. But yeah, it's basically playing with different numerical systems, right? So representation of the styles is basically going to be playing with different numerical systems. Aman V2K, thank you so much for tier 1 subscription. Thank you, thank you, thank you. I really appreciate it. So yeah, the basic system is essentially 2 colors that form a 4-bit number set, and for each number here you create a tile, and then generation of a tile, basically like covering everything with the tile, becomes trivial, right? You just match the corresponding bits. You can make it complicated, you can add more colors. In that case, maybe you're gonna have a different representation, and so on and so forth. Okay, so this is Wang tiles. I'm gonna leave the link to this website. This is actually a very cool website, believe it or not. I really enjoyed it. So you can find it in here, and for the lovely people on YouTube, I'm gonna put all of that in the description. So cool website with Wang tiles and stuff. Okay, so that's basically what it is. And what I want you to do, actually, on top of generating grid of tiles, I also want you to try to generate the tiles themselves. Right. So what if we generate everything? Not only the tile, like you know, the grid, but also the tiles themselves. Right, and we can actually go with a very simple case where we can generate gradients for each of the sides. Right, so essentially maybe we're gonna have something like this. So one color is gonna be like a circular gradient on one side, where it starts to grow from the center in here and slowly fades away towards the center somewhere here. And then the other side is going to be actually kind of similar, and it's also going to fade away toward the center. And we can generate all of these gradient tiles procedurally, and then match them together and maybe create interesting patterns with Wang tiles. You see what I'm talking about? Right, so I want you to generate like everything from scratch, down to each individual pixel, right? So once we generated a set of Wang tiles, 16 of them, we can go ahead and generate a grid and save it somewhere. Using something like OpenGL/SDL, will it be live rendering? I mean, SDL and OpenGL is kind of like a dependency. and dependency make life actually more difficult because you have to interface with them, you have to install them and stuff like that. So I was thinking that maybe we can generate everything on the level of pixels and just dump it as an image. ppm, yeah, we can actually dump that as a ppm file. That way we can do that in literally any language without worrying about dependencies, right? So that way we basically implement everything ourselves. So that's what I wanted to do. So I'm not sure how successful we're gonna be with this entire stuff, but I think it's gonna be interesting. So, and it would be kind of useful to have like shaders for writing gradients, but the thing is, you don't really need to have OpenGL to do things that you do in shaders. You can do the same stuff on CPU. In fact, OpenGL doesn't really do anything special that you can't do on CPU. The only thing GPU does is just does these things faster, right? And if we're not generating animations like 7,000 frames per second, maybe it doesn't really matter, and we can do all of that on CPU, and you can program still in the same style as with shaders, right? So let's actually give it a try. Let's actually try to write CPU shaders, if you know what I'm talking about. Let's try to write CPU shaders. Oh boy, oh boy, oh boy, where is my soy? Okay, so what was the Wang tiles, right? I call this entire thing Wang tiles. There we go. So can I have constants like width and height? So can I say like that width is going to be 64 and height is going to be 64? Is that the thing I can do? So can I also simultaneously run the entire thing? Right, something like this. As far as I know, I can do C, right, but that only compiles the thing. Can I compile it and run it? Let's take a look at the help. Okay, so compile to run. Okay, so maybe we can do something like r main.nym, and everything seems to be working. Okay, so that thing actually compiled and simultaneously run it. So this is going to be super useful. All right, so we need to open the file somehow. Nym write to file. I forgot how to write to file. It's something like IO. Okay, so we probably have to import IO. So and then we need to find the function open, right? So here is the open file function, and within that function, as far as you can see, so it accepts the file. But that is very, very strange. Is there a function? Okay, so here's the function that returns the file. So the cool thing about Nym is that you can overload functions. You have different variants like for different sort of situations, and you can basically overload all of that. Right, so we can save that in here. Then the file path. So let's actually call it something like output ppm, right? So for mode, I think we're gonna use write, right? It's basically fm write. So here is the write mode, and the buffer size probably doesn't matter, and that is basically it as far as I can tell. So, and at the end we have to close the file. So I'm pretty sure there is a function to close the file. There we go. Okay. There we go. So we can just go ahead and close it. As far as I know, Nym has a defer statement, so you can actually do something like defer. Nym defer, like in Go, by the way, like in Go. Isn't that cool? It's almost like Go. That's pretty pogue. Defer statement. Yeah, you have to actually put a colon in here, and that I think will happen at the end of the scope. Furthermore, as far as I know, Nym has like a universal call syntax. Essentially, this and this are equal. So if you have a function that accepts a first argument, you can take that first argument and put it at the beginning, place a dot in here, and call it, and these two things are absolutely equivalent. Right. So the language doesn't have classes at all. Right, it has something that is called objects, but they're basically structures. And OOP in this language is basically syntax sugar. It's just a way to call a function, right? So there's basically no OOP in here, only things that look like you calling methods. And in fact, in reality, OOP just turns into procedural programming with just a syntax sugar on chaining different things, right? So this is basically what it usually turns to. Similar to Go, but in Go, you have to specifically define the functions to be methods, if you know what I'm talking about. You have to specifically say that they're methods. In NIM, you can just take a function, and if it accepts the first argument, you can just use it like that. You don't have to specifically define it, right? It's just like, yeah, it just works like this. It's just two alternative syntaxes. Right. What is this language? I put the name of the language in title. It's Go. All right, so, and yeah, essentially I can do something like close. And as far as I know, parentheses are also optional, right? So, but I don't remember for sure, to be fair. Okay, so, and after that, I think we also have to have a write, right? So, where is the write function? Where is the write function? This is not particularly convenient to search in, unfortunately. So let me try to search for this thing. I wish documentation was a little bit better, but here it is. I can actually save a single character, which is nice. So because we're going to be writing bytes in there. Okay, so what we want to do, we want to save our images in a format that is called ppm. Have you guys heard about ppm? Okay. ppm image, right, there we go. So it's a net BPM, and specifically I want to use a variation that is called P6, right? So because it allows me to dump in a binary format in RGB. So it makes it a little bit more compressed, if you know what I'm talking about. But I mean, it's not going to be super compressed because there's no compression in there. It's just not going to take as much space as any of the ASCII formats, because ASCII formats usually take more space to represent a pixel. Right, if I remember correctly, the way you work with that, you do something like write ln, right, and you have to first put a magic symbol in here, right, so it's called P6, and then you have to put the size of the image. And I don't remember how you actually format strings in NIM. Do you have some sort of like a string interpolation? I don't remember. String interpolation of our nation. So there's the str format. Okay, so you just have to import this entire thing, right? So input str format, and then you can put some sort of an interpolator in front of this entire thing, right? And then just use width, then you can use height, and then you have to put 255, but then remember what it means. I think it's amount of, it's the range of each individual channel, right? I think that's what it is. I think it's a range of each individual channel, but I'm not sure. So let's actually try to run the program already, right? So it cannot open file IO. Which is kind of strange. So it happened, oh yeah, because it couldn't actually import IO. All right. This is a part of, oh, okay, so you have to import system, not IO. Okay, so it's doing things. The first statement not supported at top level. Really? Oh. That is very interesting. Okay, so let's create maybe some sort of a main where we're gonna move everything in here. So here is the main function, and then we can call main. Are you gonna be happy now? Hopefully. Express expected but found let keyword. So how do we define procedures? I think to nim proc. Let's actually see. NIM tutorial, this one is going to be proc. Procedures, how do you define procedures? So it's going to be proc and has to be equal apparently. Right, if I don't accept any arguments, maybe I have to do something like this. I think that's what I have to do, but I'm not sure. Okay, attempted to call undeclared routine write ln. Okay, that's really interesting. So I know that there is a routine write. So if there is just routine write, that means I have to put new lines in here. Right, is that what's going on? Main is of type proc and has to be or discarded. Oh yeah, okay, here's an interesting thing. I suppose I have to explicitly say that this thing does not return anything, right? So the type of this thing is unit, right? Okay, nim unit. Why the fuck Vim is nim so complicated? Why do you think it is complicated? I don't quite understand. Void type. So what exactly made you think that it is complicated? What precisely? Tell me more about it. Why do you think it is complicated? It has a Pepega docs bit, it's not complicated. Yeah, it's actually pretty simple language, it's just like the documentation is in fact really Pepega. So much work to define a call in function? Really? It doesn't look like that much work. Look. To define a call in function, right? So in C++ you have to have template, type name, T, then you have to have const expression, then void, then look at all of that stuff. Look at all of that stuff. So, no, you're wrong, I would say. This is straight up not true. So, I don't know where you're coming from, to be fair, right? So, where do you see complexity? So you say it's complicated, that means you see complexity somewhere. I literally don't see complexity. To be fair, what I see is that I don't really know how to do that, right? And yeah, no exception, yeah, no exception. Const, don't forget the const if you are inside of the class, right? So this is complicated. This is straight up complicated. This is not. I just like don't know how to do that because I haven't programmed that language for very long. So yeah, it doesn't look that complicated to me. All right, so let me see. So I think it wants something like discard in here, but I don't really know why it wants a discard, because I don't really return anything in here, right? Special main has no type or is ambiguous. Okay, so yeah, it has no type or ambiguous. All right, so I do remember, yeah, it has to be just this, and it should just work, but for some reason it doesn't really work. So let's actually see. Okay, so it does work, so it just does not allow me to properly call this function for some reason. So I don't really know why. Oh, now it works. So if when I was trying to do this thing, I don't know what was the problem, to be fair. Now it works all of a sudden. I probably forgot to save the file somewhere, right? I probably forgot to save the file, but apart from that, yeah, so now we have a ppm, and if we take a look at what printed in here, it actually printed /n, and to be fair, I'm not sure why. Probably because the formatter sort of didn't have like a new line or something. But you know what, I wish there was like a write new line, if you know what I'm talking about. I wish I could just use write new line in here, and it would work, but unfortunately it doesn't work like that. So unfortunately it doesn't work. So oh, it's a write line, like you see, it's a very complicated language, right? Very complicated language. Okay, all right, so now there we go, now we have that. So the next thing we can do, we figured out how to do all of this shit, so which is pretty cool. we need to do a for loop, right? So we're gonna iterate by rows, right? So we're gonna do y in, I think this is how we iterate from 0 to height, right? And if I iterate from 0 to height, I think it does not include the last element in here, but I'm not sure. So let's actually try to run this entire thing and see. So, oh, it did in fact include the last element. You see, it has 0 at the beginning and 64 at the end. Right, so and then I think you have to do it like that to indicate that you don't want the last element, I think. Yeah, it's almost like in Rust, I think. No. In Rust it's actually by default like that, but in here you have to do it like that, which is pretty convenient. Okay, so we're iterating, you know, by rows, and then we're gonna be iterating the columns, right? So here we go, we are iterating the columns. So, and for each column we can print probably... Is nim1 indexed? I think it doesn't matter in nim. I think you can have arrays that are indexed differently. Nim array. So okay, nim arrays, define array. I probably should put, yeah, array nim by example. So yeah, you can basically define your own ranges if you want to, so it doesn't matter, just like in Pascal. In Pascal it doesn't matter because you basically define whatever range you want, right? So you want a 0 based, it's gonna be 0 based. If you want 1 based, it's gonna be 1 based. It just doesn't matter. Right, so this is how we usually do that. But why does it have to use camel case? Well, it doesn't have to use camel case. Look, I'm gonna show you something. You can do something like this, and it will still work. Nested statement requirement. Oh yeah, so basically I have to actually do discard, right? So it failed in here, right? So, and it should work. Yeah, it still compiles. I can do it like that. I can use, you know, snake case. It doesn't matter. You know why? You know why? First of all, nim is case insensitive, right? It's case insensitive. You can use whatever the fuck you want for the names, except starting with a capital letter, right? So you can use whatever capitalization you want, right? So you can even do it like that. And on top of that, it also ignores all of the underscores in the names, making it style insensitive. Invalid token trailing score. Maybe you cannot do that, but as far as I know, I think you can basically place how many underscores you want. I think that will work. Yeah, that will work. So it makes it style insensitive. So if you want to use camel case, use camel case. If you want to use snake case, use snake case. Like, it's a style insensitive. Do whatever the fuck you want, right? It doesn't have to use camel case, right? So, but the only limitation to that rule is that you cannot do this. So the first letter is important because the first capital letter indicates the type. And because of that, you cannot use the first capital letter. But the rest of the things are, you can use whatever you want, right? AB, yeah. So IAB and IAB is the same. Yeah, and of course you can put this thing in front of each of these things, right? So you can just do it like that, right? So, and for different things you can have different capitalization if you want to, right? So, and in here you can even put things like that. Right, there we go. So here is your right ln, and there we go. Which makes it super easy to search for each individual call of the function. Right, so you have a function, you wanna know without using IDE in how many places the function is used. You just can't grab it, right? You have to come up with regular expressions with something like this between each individual letter. So yeah, that's basically what we have in here. It's a cool language. I really like this language. So this is going to be right line. There we go. So, okay, let's actually try to generate an image. So we have a 64 by 64 image, right? 64 by 64. So each individual pixel is encoded with RGB, and each individual channel is a single byte. So we should be able to do something like write. And as far as I know, I think you have to basically convert this thing to a character to actually write it. So the first component is going to be red, the second one is G and B. There we go. So, and let's try to run this entire thing. And is it gonna work? Is it gonna work now? Yo! And let's take a look. This is a red square that we just generated with nim in a ppm format, right? So, and it's in Emacs, in raw form, it looks like this. So yeah, the beauty of this format is that it's stupidly easy. It's stupidly simple. You just put this header in here and you just dump your bytes into the file, and there you go. You have a ppm file, and you can actually view it in the viewers that support this kind of stuff. I think that supports that, but unfortunately it kills my encoding because of the background and shit like that. So we're not going to be using that. We're going to be using Emacs as the image viewer. I can view that in Emacs, right? So we can also make it a little bit bigger. So let's actually make the size of this image 128, right? So here's 128. I might as well actually open this image in a separate buffer, right? I'm opening it in a separate buffer, and maybe I'm going to do auto revert mode, so it automatically reloads this entire thing. And if I do something like this, I think yeah, it automatically reloads every time I change something. So let's actually make it 512. Right, there we go. And it automatically reloads everything. So maybe 512 is too much. It's actually perfect, I think. So, and we can try to modify the color. For instance, maybe I'm gonna make it a little bit more dim. And boom, there we go. So it's a little bit more dim. So let's try to write shaders. Right, so let's try to write shaders. So essentially, what shaders do, they interpolate your X and Y coordinates from 0 to 1, right? So how can we do that? So U, as far as I know, just corresponds to X, right? And what we need to do, we need to divide X by width, right? By width. And we need to take V and divide Y by height. But to be able to do all of that, we'll have to actually cast both X and Y and width and height to float, and I don't know how to do that in him, so let's actually Google that. Cast to float. There we go. So I didn't expect CHR part. Why do we have to do that? Well, it doesn't really expect string. Here is the thing. It expects whatever it expects because the functions are overloaded. So you see it has a shit ton of different... Where are all of these things? I think I saw a lot of them. So write, it has a write int, but I'm not sure if write int is the one we want to use. You see, it's a single write in here, and it's overloaded for different types, right? It's like in C++, you can overload functions. But I'm not sure if it writes a single byte in here. Maybe it does. Let's actually try to get rid of it and use int1. I think it's a good point. Maybe it's not needed in here. So let's also comment it out, and let's try to run this entire thing. And let's take a look at the output. And I think it worked, more or less. Let's actually try to set the 255 and see if it actually will work. So this is going to be output ppm, and no, it doesn't work. So you cannot use just integer in here. I think, oh yeah, it actually printed it as an integer, you know, in ASCII, right? Because we want to print a single byte. That's why we want to do that. All right, so let's try to do that one more time. Okay, there we go. Here's the thing that we wanted. Okay, so how do you cast to float in nim? Cast types, type casting, casting, I don't know how to pronounce that, I'm sorry. Okay, so it's a type conversion, so you just wrap it in a particular type. So maybe that's precisely what we want to have in here. So I'm going to do float, there we go, and I'm going to just wrap it like that, boom. So another one is going to be float, and here is the float, there we go. And now we have UV coordinates. Shigeman subscribed for 7 months.
Hi.
Hi, hello, how are you doing? Thank you so much for 7 months of tier 1 subscription. Thank you, thank you, thank you. And welcome to our epic anime club. How about that? How about that? Bet you didn't expect that? Alright, so now we have U and V interpolated, right? So we have U and V interpolated, and they're basically values from 0 to 1. We can create a function called frag. Right, so this is going to be frag, which accepts UV coordinates. I think you can actually pass, you know, arguments like this, if I'm not mistaken. You can basically group them together if they have the same type, just like in Pascal. And here we want to return the color of that 1 pixel that we generated. Right, so how can we return? I think we need to have a custom type, but maybe we can use tuples, right? Because Nim has a tuples, if I remember correctly, right? So it's going to be tuples. Ruples tuples. Okay. So tuple. So they're named tuples. I think you can just straight up return something like this, right? So do they have to be named? Anonymous field syntax. Okay, this is actually perfect. I can probably return float, float, float. But to be fair, I'd like to have names in front of them. I think that would be kind of cool, where I could say that this is red, this is green, and this is blue. And this is going to be a normalized color, meaning that each individual component is from 0 to 1, you know, the usual stuff in OpenGL. Right, so this is going to be tuple, and there we go. So, and how do I construct such tuple? I think we can give it a try. Can I construct it like this? Right, so let's try to compile this thing. Boom, it in fact compiled, but not used. Okay, so because we never actually passed this entire thing. So this is a simple shader. Right, this is a simple fragment shader that we can use. So after that, what I'm going to be doing, I'm going to be calling this fragment shader on these UV coordinates that we just created. Right, and I wonder if I can now just take RGB, right, and destructurize it like this. I think I should be able to. Let's actually try to compile the entire thing and see if it... Yeah, I can do that. So this is actually super convenient. Right, and after that we want to convert each individual float to the byte. Right, since it's a value from 0 to 1, we want to multiply it by 255 and then convert it to it depends what CHR actually accepts. It depends on what it actually accepts. Let me see. So CHR, show me your wisdom. It's a range. Oh, this one is interesting. This reminds me of Ada. Wait, that's cool. It doesn't accept any particular value. It accepts a range from 0 to 255. It's like almost like Ada. Right, in Ada you can define these integer types that are ranges, and depending on the architecture it's going to be just like represented differently. This is actually pretty cool, but I think I'm gonna just do integer, hoping that this is going to work. Right, and I'll have to do that for each individual component actually. So G and this one. RGB. It combines successful concept from mature languages like Python, Ada, and Module. Yeah, you know, this is a very successful concept. This is the most successful concept I've ever seen in my entire life. This is so... I can feel the success. Alright, so feel the success. Alright, seems to be working. And did it work? Did it work? I think it didn't work. Oh yeah, there we go. So we have a shader. So this is a classical UV pattern, by the way. We generated this shit, by the way, without OpenGL. Again, people, you don't need GPU and OpenGL to generate a single frame that looks like this. you just don't. Right. The only reason why you need OpenGL is that you want to generate 7,000 of them per second. Or maybe more, maybe like 10,000 of them per second. We don't need to generate 10,000 of them per second, right? We just need to generate one once in the blue moon. So yeah. There we go. So, and essentially the way you do that, you just take X and Y coordinates, you transform them into 0 to 1, right? 0 to 1. And then you have a single function that maps these UV coordinates to RGB, and then you save those RGB to the file. All right, so let me see. Now what we can do in here, I don't know, we can probably put some sign in here, and again, since we have a universal call syntax, I can actually do something like this, right? I can actually call sign like this. This one could be cosine, and it's not going to work probably because I have to import math or something, right? So you see sign is not available, unfortunately. So let me make a wild guess that I have to import math. And it was correct apparently. So let's revert the entire thing, and there we go. So here we have this shit. Interestingly, maybe we can make it repeat a little bit faster. Again, I can actually put it in here and maybe multiply it like by 10, right? Right, multiply all of that shite by 10, and let's see what's gonna happen. Output, revert mode, and boom. Yep. Something, oh, unheld exception value is bigger. Oh yeah. You know what's going on? This entire shite is from -1 to 1, but these things have to be from 0 to 1. So you have to do the classical thing of actually, adding 1 and then dividing all of that shit by 2, right? Maybe you can multiply it by half like this, and then we go here, and there we go. We've got this kind of pattern. Changed on disk, yeah. Okay. So Emacs is actually kind of going crazy on me right now. I don't know why, but it is what it is. We can probably save this like parameter n to here, right? Something like this. It's going to be like that, and then I can try to recompile the entire thing. Why does it ask me, change in disk really edit the buffer? I don't really edit anything. Why do you ask me to edit it? I really don't like that it asks me shit. So maybe it would be better if we had other program that could live reload images. Maybe something like feh, right? So is feh capable of doing that, boys and girls? Does anyone know? So first of all, the problem with feh that I don't like, I really don't like it. It has this, like, checker pattern background that ruins the entire encoding. You can actually see that. So do you see the pixelated Zozin? Do you see the pixelated Zozin? This is me. This is a pixelated Zozin. Thank you, feh. Very cool. Right. So this is a huge problem, especially if you are a streamer like myself. So you have to put some sort of like a background color, right? So yeah, so you can put B style as a background. I think you can do something like feh. How do you pronounce feh, by the way? Feh. So I think you have to put -B and you say something like black. And there we go, you have a black background. I think it's actually pretty cool. All right. So now can I reload? If flag is .feh will reload the current image instead of switching to the next one. All right. Okay, specify a shell command as an action to perform on the image. In a slideshow or multi, the action will be run when action 0 key is pressed. Okay, auto rotate, reload, preload, reload, first the current image after, useful for viewing HTTP webcams frequently. If image is removed, feh will... Okay, we can use that. but it's an integer, right? Is there any way to reload on changes? So there is this sort of thing. So you can trigger that automatically. Arthur, do you have, I mean, I would have found it if it was existed, because I'm literally incrementally searching by reload. If it had auto reload, I would probably find it already. So this is the, there is a reload after each second, but I don't see any reload on modifications. So what I see is basically reloading each second, or reloading on request, right? So by pressing R or something like that. So we can try different things in here. So first of all, I'm gonna actually grab this entire thing and maybe run it in here. There we go. So then I can probably split my screen like so. Can I actually make it smaller? Right. So because I want to be able to see this shit. And now if I have some stuff in here, right, for instance, I want to maybe modify this thing like that. So now we're gonna have something like this. All right, and where is my compilation modus? This is not what I wanted. I wanted to rerun my thingy. And now I press R, so I can actually reload everything automatically. So you know what's cool is that this thing is resolution independent. Right, it can scale up and down as much as you want. If I want to make it smaller, I can make it smaller. Compilation, there we go. There we go, and now it is in fact smaller. There we go. So it's 64 by 64 now, because we are not calculating pixels by their absolute values. They're calculating the colors of the pixels by interpolated values from 0 to 1, so we don't care. And furthermore, it is even a ratio independent. I can make the you know, the width bigger than the height, and it still will work, because the shader function here doesn't know anything about resolution. It just has UV from 0 to 1. It literally doesn't care. Right, there we go. Boom. So it just squashes it. And all of that without any shaders, like completely on CPU. See? If you have a very simple case, and you don't generate too much of the shit, you can just do that on CPU. You don't have to do that on GPU. Come on. So yeah, isn't that POG? Isn't that POG, fellow case? I think it's pretty POG. Why is the args called U and V, by the way? I think for the same reason why coordinates are called X and Y. Why? No idea. It's a convention. Right, so when I reload thing, by the way, does it? It also actually brings it back. Yeah, alright. So I actually want to change the resolution in half. Right, we're changing the resolution in half. And there we go. So this is one way to do that, right? So we can manually request the reloading, which might not be super convenient. Right, another solution would be, to put something like, was it R, and reload every second, right? Which makes it blink. Do you see the blinking when it reloads every second? I'm not sure if you can see that, but it freaking blinks for me every time it reloads. So I can see the blink. Holy shit, like, it can't even reload it seamlessly without messing. Oh my god, this is so bad. Well, I can see that. That's the problem. You had such a simple job of displaying an image and auto reloading the image, and you can't even do that. It's just like, my god. So I didn't even know what to say, to be fair, boys and girls. I didn't even know what to say. It's such a simple thing to do. Maybe I have to write my own image viewer just to be able to do this kind of stuff. I don't fucking know. These days I don't fucking know. You know, it would be nice to have this kind of thing on this bar. But unfortunately, we don't really have that much space in here, right? So if I'm gonna put it in here, this is how much chat we're going to have. So I'm not sure if I'm gonna do that. So, but at the same time, So this is too much space in here. This is too much space. Yeah, maybe it's fine. I don't know. We'll see. So alright, so we have something like this, and yeah, for the other things we can do something like u plus v multiplied by n multiplied by n, and that's plus 1 and multiplied by half, right? And there we go, right? So, and then I can reload this entire thing, and now it has additional strips in here, which is actually kind of cool, I think. This kind of additional strips are really cool. I didn't expect that. Huh. So if we make it even bigger, like, right? So these strips become visible, but at the same time, if you make it like this, yeah, it becomes something like this. All right, so we have fragment shaders, right? So that's basically what we have in here. We have simple fragment shaders. You can change the resolution. You can make them bigger if you want to. Right, so now they're way bigger. They have more stuff in them. And so the next thing we want to do, we want to generate the corners, right? We want to generate the corners. But I think we're gonna do that after a small break because I really want to make another cup of tea. The letter U in V denote the axis of 2D texture because X, Y, Z are already used to denote the axis of 3D objects in model space, while W in the addition to X, Y, Z is used in calculating quaternion rotations. Yeah, I was right. For the same reason why we use X, Y, Z. Nobody knows, right? It's just the convention. For the same reason why we use I as an iterator variable. So yeah, it's just like basically the, convention. Nothing particularly special. What kind of tea? The special kind of tea, if you know what I'm talking about. Because the next blue and one don't look horizontal. Interesting. By the way, do you guys want me to upload this thing to GitHub right now so you can play with this? It's actually, this is a single file. That's what makes it cool, right? So we're generating some interesting shit with a single file, and this will work in any language, by the way. So you can easily rewrite it in any language you want, and it's going to be the same thing. Right, so let's actually create readme, like readme md. Okay, Wang, so gradients with Wang tiles in nim, right? And we can actually point to the nim programming language. The pull request to rewrite the entire thing in Rust. Unfortunately, these days I don't really look at my notifications on GitHub anymore because I have too many of them and I just couldn't be bothered, so I'm sorry. So yeah, I'm really sorry. I feel like an asshole, but it is what it is. It's just like too many things that are not even that important, so I just don't bother. If you have something super important to bring to my attention, try to ping me on other platforms. So yeah, I'm really sorry about that. It's just like too much for me, and like lately my mental health is actually pretty low, all-time low. Right, if you know what I'm talking about, all-time low. I have this feeling in my body. So, and I just like couldn't be bothered by notifications. I'm really apologize for that. So yeah, the thing we want to do here is going to be nim, right? And that's basically what we have in here. And then you do the and output ppm. So this is basically a quick start. And the license is obviously going to be MIT. You can do whatever the fuck you want with it. And we're going to git ignore the entire thing. So this is going to be main, this is going to be output ppm. And also maybe we're going to say that you have to install install nim compiler first, right? So HTTPS, right, HTTPS, and there we go. And here's the entire instruction, nothing particularly special. So git init and what are you asking? Okay, I don't know why it was asking me this kind of stuff. So, and yeah, ready, set, go. And how should we call this entire thing? So I already called my folder Wang tile, so maybe I'm gonna actually call the repo like that as well. Wang tiles, there we go. So I'm not gonna put any description yet because I don't really know what exactly we're doing. We're just experimenting with these things. And all right, add origin, and I'm gonna push this thing in here, and yesu, kawaii freaking desu. Want tiles. Oh shit. Okay, so we'll have to rename it. Let's see through how many loopholes we have to go to actually rename this thing. Right, so we have to rename it. Oh, we didn't even ask my password. I'm actually surprised. All right, so you can find the repo in here. So it's a single nim file, nothing particularly special. It's actually pretty readable, and it's not complex at all, right? So it's just like, it's almost like Python. Would you look at that? It's almost like Python. It even has like a style of Python. Like in Python, you also have if underscore underscore main underscore underscore equal something something something, then run it. Otherwise, don't run it or something. Yeah, and especially like defer. I think more languages these days should have defer. All right. So, and now we're gonna actually put this entire thing in the description as well for lovely people on YouTube who's watching on YouTube. By the way, if you want to be a lovely person on YouTube who's watching me on YouTube, you need to subscribe to this channel, right? And if you're watching on YouTube and you want to watch me live, go to HTTPS, right? So why do I have a C++ in here? Go to HTTPS twitch.tv/sodding and follow me there, right? So you see, you can be whoever you want to be, right? You want to be a Twitch person, go to Twitch. You want to be a YouTube person, go to YouTube. The possibilities are unlimited. My God. My God. Anyways, so yeah, we also need to update the project command. So here's the source code, and where is the project command? So project generating gradient with Wang tiles. Right, so I'm gonna update cmd project, and we're gonna say source code, and we're gonna put this thing here. So also I'm gonna put this thing like this, or one sender. And let's put this thing like that. Did it work? Okay, so it seems to be working. It seems to be working. There we go. Cool. So now what we need to generate this idea I was talking about at the beginning of the stream, where yeah, we have different gradients, right? And we're just like putting them on different sides. And also we need to think how we're going to be merging the colors in here. So I don't think I want to merge them too much, because otherwise the tile's not going to fit properly on the corners. So maybe this is going to be like a hard line between these things, but we'll see. And by the way, another interesting thing is that generating circles with this kind of style of shaders is actually super easy. Oh, and by the way, you can have actually several shaders in here. So here we have I don't know, stripes, right? So here's the stripes shader, and I just use stripes, right? And then I can create another shader. So you see, I can have several functions that represent these fragment shaders, and I can swap them out, and that will work. So another one is going to be a circle, right? You accept UV coordinates like this, and you return a color. So I wonder if we can just do something like type RGB, right? So, and then I can say that I'm returning RGB in here. and I'm returning RGB in here. I think I should be able to do this kind of stuff. So, and in here, we need to find the distance between the center, and the center, by the way, is located at center X is located at half and half, half and half. So what do? We do Cx minus U, probably, oh yeah, we're basically subtracting this entire thing. So, and the second one is going to be Cy minus U. It would be nice to have a vector library, you know what I'm talking about? Right? Because the cool thing about GLSL, for instance, is that you have all this vec2, vec3, vec4, vec69, matrix 4x4, matrix 420 by 69, and all of them have these very cool operations, and they're very, very convenient. So we need something like that. We need something like that, and I think we can implement that pretty easily. At least I can implement vec2, right? So I could probably try to. And to be fair, vec2 is essentially just a tuple, right? X float y float, and then as far as I know, nim has operator overloading. Yeah, you can actually overload operators in nim, just like in C++. So operator, hater, okay, so where is the operator? This is not what I wanted, Mr. Nim. Operator overloading. Overload resolution, operator overloading, and negative failures. I just need an example, please. Oh yeah, this is how we do that, I think. Right, so you say something like proc, right, you put the backticks, and then you say plus, and then you accept two things in here, A and B, which are vec2, and then you return vec2, and that already overloads this entire thing, as far as I know. So I think you just can construct a x plus bx, a y plus by, and there we go. So you can have different operations in here, right? Query replace plus with minus. Is it really minus? Minus looks kind of sus. Yeah, it's actually minus. Then query replace minus with this thing, and then you can do something like query replace this with that thing, and we already have like a, you know, linear algebra thingy. So it wasn't that hard. I'm not sure if this entire shit compiles, by the way, so we'll have to also test how it compiles, but yeah. So, and another interesting thing, algebra. Yeah, as far as I know, you can also have generics in here, right? And maybe with generics you can parameterize how many of these things you can have in here, but I'm not sure. So let me see if this entire stuff compiles. I'm gonna comment out this thing, and what we're gonna have. Yeah, this works. Yeah, you can basically overload these kind of things. Gradients with Wang tiles? Rings. Like nice idea to create a Perlin noise fake without actual math. Nice. That requires exquisite emote. Yeah, exquisite. We'll go. Yeah, you need a glass of wine while you read this message. Yes, exquisite indeed. Yes, yes. Gradients with Wang tiles. Yes. Perlin noise. Yes, yes. Yeah. So we have this kind of thing, and what I wanted to do, I wanted to actually generate a circle. Right. So let's go ahead. So this gives me that, but on top of that, I think I'm gonna have dx, and then I'm gonna have dy, and I suppose we can have something like if the dx dy plus dx because it's a square, right? Dy is less than what? I suppose 0.5, right? So it depends on the radius, right? So less or equal than the square of the radius, and in this case the radius is going to be let's say 25, right? If it is, we're gonna be returning, I think, a red color, right? So this one is gonna be just red. There we go. So here's red. Otherwise, we can return black, right? So let's see if this entire thing will compile. Let's see if this entire thing will compile. And yeah, so it seems to be compiling. Can we use that thing now? Here, right? Can we use it here? And where is my thingy-majingy output? And that worked, as you can see. That's a pretty cool circle. It's a very cool circle. Yes. Okay, so let's try to understand what the hell is going on. So you have a center. And you have, oh, okay, I already found the bug. Okay, that's cool. Alrighty. And boom, there we go, we generate a circle. So that's how we can generate. Easy. So we're generating it pixel by pixel. So for essentially for each individual pixel, we are checking, is it within the circle or is it not within the circle? Right, we can make it a Japan flag if you guys want, sure. It's just like means that I have to make this color white. Easy. Alright, so, and cool. So this is a Japan flag. Yeah. Japan flag generator, exactly. But the Japan is supposed to be like wider and shit. So yeah. So if you make this entire thing wider, right? If you make it wider, it's gonna look like shit. By the way, just saying. Boom. Right. So you need to be sort of like aware of you know, resolution and shit. Stretch to yeah. But to be fair, I don't know how easy to do that. So let me actually query replace circle with Japan. Right. So this is the Japan shader. This is a Japan shader. And freaking this. I wonder if we can actually make it branchless, if you know what I'm talking about. Can you make it branchless? If you save this entire thing to a separate variable, right, you save it to a separate variable, and then what we return is, right, we want to convert it to C, actually to float, right. If it's true, interestingly, we always want to put 1 in here, right? It's just basically, if it's true, we can try to invert it, right? So that means it's going to be int float C, there we go. So, and this entire shit, I think, becomes branchless. Oh yes, it does. Look at that. It's branchless, right? It doesn't have any if conditions or anything like that, so we're using directly the value of this condition. Is that, does that make it branchless? I think it does, kind of. Yeah. So is that what branchless programming means? So you can actually use different colors now, right? So if you're not happy with the red one, right? So you can basically probably use the green one. There we go. Optimization on, yes. There we go. So now it's a green one. So that's actually a pretty cool idea, I think. Huh, never thought about it. So the thing we want to probably do in here is also, you know, be aware of proportions, if you know what I'm talking about. A little bit, just a little bit. Branchless code means the no dependency tree. Cool. So we know their entire resolution because it's global, right? It is global. Now, what we can do, we can probably take the aspect ratio of this thing, right? Aspect, which is I guess, height over width, right? But to do this kind of shit, you will have to do float, right? Float, and there we go. You have an aspect ratio. Is it gonna help us somehow? I have no idea. Probably not. So one thing we can probably do is maybe multiply aspect like this. But like every time I work with aspect, it actually blows my mind. So I don't think it's gonna be like a useful thing. Yeah, it's actually fucked it up. Okay, so I'm not gonna do that then. And what I want you to do, by the way, I want you to make a small break, boys and girls. I was about to go on a break and I went on a huge tangent. So yeah. All right. So aspect is declared, and yes. So for some reason I don't have a built neuron path in my brain to work with aspects something like that. I don't know why, but yeah. So let me actually also commit whatever we have in here. You know what? We could do the following thing. I can accept the UV as vec2. I think that would be actually kind of cool. So UVX, right? So this is a UVX, then UVX, UVY, UVYN. There we go. So we accept vec2 and then RGB, and here we accept vec2. So, and because of that, we can have a center, right? Center, which is effectively half of this thing. Right, and then we have D, which is basically center minus UV, so we compressed these two things. And for the vector, we can also define something like length, right? So it's going to be length, which is essentially, all right, so this is a vector, vector2, and right, so it's going to be x plus y. Y, and we can take SQRT of this entire thing. I suppose it has to be float. Yeah, length has to be float, unfortunately. All right. So, and after that, I can say, yeah, the cool thing, again, since we have a universal call syntax, I don't have to do length D. I can say D length. Yeah, I can just do that. And I think even parentheses are optional, right? So, and then I can just do something like this. So this is that, and is it gonna compile? Is it gonna compile? Probably not. Yeah, it didn't compile. So 28 predefined C. Oh yeah, because this is a center now, and how should I call this thing? So this is a center, this is the difference, and this is, I could call it as R result, so it's actually called A. I don't know, like I'm running out of letters to work properly, unfortunately. Okay, so what do we have? Type mismatch, got float. Okay, so the line 40. Oh yeah, so now what you have to do, you have to actually call it like that. There we go. All right, so you have to be able to construct a vector out of this entire thing. And is it working? Is it working? It is in fact working. It is in fact working. So we have a simple library that works with vectors. Look at that. So you only had to define a tuple and overload a bunch of operators in here. So that's pretty pog. Another interesting thing is that we only use D in a single place, right? We only use D in a single place. We can actually inline D like this. Right, so there we go, we just inlined it, and that's fine, I guess. Right, so that's fine. And another thing, R is actually, I mean, again, it's also used only once, so you can basically keep compressing this entire expression more and more. And it would be nice to be able to construct a vector from a scalar. If you know what I'm talking about. So maybe we're gonna have something like proc vec2, which accepts a single scalar and returns vec2, but effectively what it does, it just, you know, duplicates this entire thing, right? And that way we can say that the center is vec2 05, but in fact it just, you know, duplicates it into into a vector, and then we're subtracting the UV, and this is how we get the length. And this entire expression is way simpler and way easier to read, by the way, in my opinion. Right, look at that. I think it's beautiful. Yep, it's actually way easier to read, I think, yes. So, and this entire thing produces the Japan flag, right? The right abstractions at the right time make all the difference, Mr. Freeman. So, it's pretty cool. It's pretty cool. So, I only wish that NIM was not a toy language. Okay, I wish two things. I wish it was not a toy language, and second thing, I wish it didn't have this bullshit. So, yeah. And the reason why I say it's a toy language, it's literally preprocessor over C compiler. So, this doesn't help me to take it seriously. I just can't take this language seriously, I'm sorry. Anyway, so, but it has a lot of cool ideas. So, and it's also a preprocessor over CPP, and it's also a preprocessor over JavaScript. You can actually compile this entire shit to JavaScript. I'm pretty sure it's not gonna work. So the way you compile to JavaScript, you put JS in here, right? And okay, it actually compiled to, okay, so we just generated JavaScript out of our code. So, okay, so we have a JavaScript. Oh, I think I know what the fuck it is. I think I can now run this thing with Node. Can I? Can I run this thing with Node for slower performance? Okay, I can't do that, unfortunately. fopen. Oh, okay, so it generated JavaScript, right? It generated JavaScript, but it cannot find such thing as fopen. Okay, thank you very much. They could have implemented that, I suppose. I don't know. But yeah, in here. Okay, so this is the new. Alright, so, and this entire thing generated as the Japan flag. Have you tried using the yes? You won't believe how many languages I tried. You won't believe how many of them tried. You can do much with a toy language. Trust me, I know a lot about using toy programming languages in production. The entire world uses JavaScript in production, and it's a toy scripting language designed for verifying HTML forms. That doesn't change the fact that it's a toy programming language. So, I wanted to make a small break. So let's make a I think, yeah. So maybe I'm gonna also put the display lines so it doesn't confuse the people. All right. So, all right, let's make a small break, and you guys have fun, I suppose. I'm gonna make a cup of Earl Grey. All right, so I have my tea, and let's continue. So the thing we want to generate in here is not really a Japan flag, even though we could generate a Japan flag. We want to generate like gradients and shit. So maybe I'm gonna have a thing called Wang, and we're gonna accept UV coordinates, and we're gonna return RGB. Right, so that's what we're gonna have in here. RGB. So what we're gonna start with, I think I'm gonna start with just 4 circles, right? So, right, we're gonna have a circle on each individual side in here. And that way we're going to generate a single Wang tile, and we'll see how it goes, in fact. So the first thing, let's find the position of this point, right? So the position of this point, luckily, by the way, we're not following the OpenGL coordinates, so our UV coordinates are actually like this, right? So because we're using like screen coordinates and whatnot. So this point is located somewhere at, so by X it's half, but by Y it's 0. So here is the thing that we have in here. So then we can take that thing and subtract UV, take the length, right, we're taking the length, and the radius, I suppose, right, is going to be used for all of the 4 circles, is going to be greater than 25, and that way we can basically use this thing like so. It's kind of similar to whatever we have in Japan, so which is kind of pogue. But in case of this thing, I think I'm gonna use the black color for now, right? I'm gonna use the black color, and let's see what we're gonna have in here. So maybe I want to actually run this thing like that, so we can constantly reload into. Oh my god! Okay, I almost screwed up everything. What I want you to do in here, I want you to just, you know, put it like that. Okay. Boom, 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 boom. Okay, so identifier V32. So this is supposed to be C, and let's see what we have in here. So here is that, and this is what we've got, which is rather strange. Right, first of all, I would like to have probably a bigger radius. So the radius probably have to be maybe half, so it takes the entire thing, right? So it takes the entire thing. Right, so did it do the trick? Oh, okay, so I should actually use the radius in here, right? There we go. Okay, so here is that. Interestingly, I would like it to be a little bit more squashed, but I guess it's fine for now. Right, it could be fine for now, though it actually goes straight up into the center. So if we have 4 circles in here, and we'll make them properly intersect and whatnot, maybe it's gonna even look good. But when they intersect, the question is how we're gonna do that. So yeah, it's gonna be a really interesting question. Anyway, so if I put 1 in here, is it gonna... Oh yeah, that's basically what gives the color. So, and if I want to use like black color in here, I think I have to invert this condition. So let me see. Yeah, there we go. So that's kind of what we wanted. A mugs, yes. This is kind of sus, not gonna lie. This is truly sus. All right. So this is the first one. Right, this is the first thing. So, what's gonna be the easiest way to add the second one? So maybe we're gonna have a sequence of these points. Right, sequence of these points, nim sequence. Right, I remember that nim had some sort of a sequence and whatnot, and I would like to have some sort of examples to see how you're supposed to work with this kind of stuff. So we can have this kind of thing, but maybe that's not what I want. Right. So this is how I can define sequences. Right. So if I put CS in here, this one is going to be at. And here is the first sort of center, right? So here is the first center, and can I do something like this? Is it going to work? It seems to be working. Okay, cool. So the second point that I would like to have is going to be, so it's on X it's also half, but on Y it's going to be around here. So this is the second point. So what we can do in here, maybe we can map those things. Okay, so I remember you could map them. Yeah, you can actually map this entire shit. That's pretty pogue. Right, so we have a sequence, you can map it into a sequence of colors, and maybe you can then collapse those colors into something. Right, you can essentially collapse them. But before we collapse, I want to know how you can make the black background, right? If you know what I'm talking about. I think the easiest way to make a black background, so if it's within, right, it's going to be like that, but if it's something like this, it's going to be something like this, right? Right. There we go. There. Now we're talking. Now we're freaking talking. Okay. So, and essentially. So this is only for one thing. I can do CS, and then we are effectively mapping this entire thing with a procedure. So the procedure is going to accept the center, right? And this is how we do that. So this is going to be just like this. I'm not sure if I... yeah, I can just do equals, right? So it's going to be C, and in here... I can just grab this thing and put it inside of the float, like so, right? And that gives me a sequence of the colors, right? So is it gonna compile? Hopefully. Call undeclared routine map. So map is probably located in sec utils. So let's actually import this entire thing. There we go. Red sun. Yeah, typeless parameters are obsolete. Oh shit. So you have to provide the type of this thing. Okay, so let's actually do vec2. All right, vec2, and so expression is of type float, float 64, and has to be of type, or has to be discarded. Yes. So so this is colors, right? So this is centers, and these are the pixels. Okay, so let's actually call PS, and then we need to grab this entire thing. All right, so it didn't work. That's really strange. Oh, this is because, okay, I see. Right, you have to specify input and return type, and if you don't specify the type, it thinks that you discard this thing. I think it will depend. I think it is working now and it doesn't break. Okay, that's perfect. That is in fact very much perfect, and I wonder if I can just put this thing like that. Right, so for a little bit of a convenience, but I'm not sure, it probably doesn't matter. Okay, so now what I want to do, I want to actually, so I have a sequence of centers of the circles, right? So I have two centers, one here and one here. I map through this entire thing, generating a sequence of colors, and now I want to compress these colors together.
23 Montkaz, привет.
Thank you so much, I'm a Robot, for 23 months of tier 3 subscription. Thank you. That's a pretty generous subscription. And yeah, привет. Hello. Thank you so much. Welcome. Alrighty. So I need to now compress this entire shit. So can we have something like reduce or fold? It's called fold. Okay, so the fold L. And to be fair, all of this map and folds are pretty cool when you are young and, like, you know, CS grad student or something like that, but over time you realize that all of that shit is actually easier with for loops, believe it or not. It is in fact all of that easier with for loops. Because in for loop you can map and fold simultaneously, if you know what I'm talking about. Right, so you can have the final result somewhere here. I do realize it is actually kind of cool when you're new to programming and you discover this like new paradigm, like holy fucking shit, map, filter, reduce, it's so cool, it's so scalable, you can parallel that. But in reality, it's just in for loops you can do that way easier, right? Because you can compress a lot of these operations into a single for loop, and it's just basically the same shit. And I do understand that a lot of people will disagree with me because they didn't go through this phase of functional programmers, but it is what it is. You'll have to, you know, deal with that, my friends. So what can I actually use fold specifically here? Sequence and it's not the face. Yeah, sure. I'm thinking how am I gonna combine them. So do I want to do something like max? Yeah. Haskell and other advanced languages have the ability to fuse the separation. I heard that so many times. It's the same shit over and over again. Yeah, sure. Okay, let's actually do the real work in here. So what do we have? So what's gonna be the easier thing to do? All right, so I'm gonna just return always maybe a red, right? It's the same shit for like 30 years. Okay. So, can I just do for C in CS, right? And for this entire thing, I essentially just generate that, right? And that gives me the color, right? That gives me the color. And where I'm gonna put that color? So it's gonna be T, and yeah. Okay, and so this is gonna be the center, right? So this is the center, and maybe here we're gonna even have also corresponding center and its color. You know what I'm talking about? Center and its color. So and then with these kind of colors, we'll be able to actually like pick the color we want. Okay, so and I want to be able to work with RGB like with vector and being able to do operations on it and whatnot. So what I'm thinking is that we can probably introduce like the second vector type, right? 0x746 C62 Tsodimpok, thank you so much for 2 months of Twitch Prime subscription. Thank you. I really appreciate that. What does your nickname mean? Let's actually find out. So we have effectively does it say Pog or something? Wait a second. 0x. So hex 70. Ah shit. T. I wish. Well, okay. So this is T. And then 6C TL62 BLT. It's either TLB or BLT. So I don't know what precisely it means, but maybe we can actually try to convert it to decimal, and in decimal it also doesn't really make much sense. Okay, so it's probably something special for you. All right, I couldn't decode that. You won this one. Yeah, it sounds like it's a bacon, lettuce, tomato. Yeah. So it's basically your name is a sandwich. Congratulations. We decoded that your name means sandwich. God cryptographers. All right, so let's continue. So essentially what I want to have in here, I want to have the second type, which is yep, sandwich. Was it true? Did we crack it? Did we actually crack it? I think we did. I don't know, maybe. All right. So this is gonna be vec3, and I want to have a similar operations. I wonder if I can generalize that even more. So nim generic values. Can you have values? But I'm not sure if it's that good of an idea. So let's actually Google for generics, because I want to have like a vector. Yeah, I don't think it's gonna work for tuples, unfortunately. Oh, if you make a tuple an array, it may work. If we make a tuple an array, it may work. So let me see, where is the array stuff? So where is the array? So here is the arrays, right? And you accept a range in here, and we can actually put, I think, yeah. So essentially we can probably have a vector, right? Type vec, which is effectively an array, right? And I wish there was an easy way to have generics. So the problem with Nim is that it doesn't have that many good examples. It's just like really sad. Generics examples, right? And it's just like Google is incapable of finding anything. It's just so bad. Okay, generics. Okay, so we can have that, but this is just a type, and the thing I want to have is just a value, right? So templates, you can have templates, okay, and maybe some other things and some other stuff. Part 3 and generics, generics. I remember there was a pretty cool example, you know, that showed how to implement a matrix in Nim, and I think it was using the generic values, right? Nim generics matrix or something like that. I think we even looked at it. So array length, tuple, fields, linear algebra. Okay, maybe we can actually take a look at some linear algebra thing in here. So here is the linear algebra, linalg nim, and okay, so there's some private types. I think we need to take a look at the private types. So, this is a wrong folder. This is a wrong folder. Go back, please. Go back. So it's a linalg private types. Okay, so maybe we're gonna have something in the types. Static int. That I do remember something like that. Yes, I told you. Freaking told you that I do remember something like this. Yeah, so that's how we do that. So that's cool. So we're gonna use this kind of shit. Okay. So when they also do that as an array, okay, that's nice. So and the thing I wanted to do here, so it's gonna be n static int, right? And in here it's basically n, I guess less than n. I hope it's gonna work, but unfortunately it has to be float. And I wonder if I can use usize in here. Is there something like usize? Nim usize. Nim usize uint. Probably not. So we can actually use int. Uint. There is uint though. I need to find the len function. I have too many things opened, unfortunately. So I need to close some of this stuff. There's too many things. So this is going to be a len, right? This is going to be len. And len always returns int. So they use int as the size type throughout the whole language. Okay. So that means we're gonna be using int in here. All right. And now so the problem with array approach, right, is that there's no particularly convenient way to access x and y, right? So if you have a vector like uv, vec, let's say 2, right, you'll have to access this thing as 0 and 1. So maybe we could define some sort of a constants x0, y1 to access this entire stuff. Oh, this is actually even cooler idea, I think, because we can similarly define also r, g, and b. And I wonder if I can define several constants at once. I think there was a way to do that. Okay. If I remember correctly, I think there was like a way, like almost like in Pascal, you know what I'm talking about? Yeah, I think that this is a thing. Is it not? I think it is, right? So, and then our, yeah, I think it is a thing. And at least the Emacs mode does not complain about this stuff, so I can probably use that. So, and every time you have a UV, you can access it as X, And furthermore, we can have an aliases for UV stuff, right? So UV is 0, the V is 1. I think the third coordinate is usually S in the textures, I think, right? So UVS coordinates, UV mapping. Is it not? Is it not? I don't remember. Does anyone remember what's the third one usually? What's the third one? Texture, 3D texture coordinates. What's this? I think it's. I don't think it's W. I think it was S. Okay, so let me see. OpenGL 3D texture. So 3D texture. I hate source code as an archive. I really hate that because it doesn't allow me to quickly look at this stuff. So image 3D. Oh, okay. In case of a texture, it's str or something. Okay, so I think I'm not gonna do into that. So there's also, I think UV is not really texture stuff. It's a normalized coordinates, and texture coordinates is a completely different thing. Okay, so we're gonna have aliases only for these things. So I think it's gonna be fine. So I want to first check if this const thing is working. Right, so we need to check that. Okay, so vector redefinition of vector. Oh, this is because I copy pasted this entire thing. Okay, so let's remove the entire thing. Okay, that works. So that means I can combine this kind of shit like that. That's perfect. So I can probably also do this kind of stuff, right? All right, so let's actually make the vector a little bit more generic. So we can have like 3 dimensionals, 2-dimensional, 3-dimensional, 4-dimensional. Let's do something like this. So we're gonna have a proc vec, which is gonna be n static, and we're already gonna get a pretty complicated shit. I already don't like that. All right, so, and the result of this thing has to be vec n. And yeah, this is actually pretty cool. So nim also automatically generates a result variable for you, which means we can do something like I in 0 n, right, and result I equal s. So that's how we can do that, right? So I wish it didn't have a static. I think static syntactically makes it kind of difficult to read. I wish it was something like just this. You know what I'm talking about? Because like this static thing kind of makes it noisy. What do you guys think? Like it would be way better if it was just that and way more readable in my opinion. Right. So yeah, I do understand why static is needed, but it just makes it way noisier than it needs to be. But again, it's just a syntactical thing. It's like a bike shading. Yikes. Okay, so what do we have in here? So I suppose here we're going to be accepting 2 of these vectors, right? So here's that one, and yeah, I think I'm going to actually remove this thing. Vec n static int, it accepts n and returns vector n. Vector n, and in here is going to be I in 0. I wonder if I can iterate the result thing directly. I wonder. Okay, nim for each array. I wish there was like a little bit better. For statement. For statement. So we have an index and we have an actual value, but I also want to be able to iterate this entire thing by reference. Right, ideally I would like to have something like this where I have a component and then I just iterate the result, and I also set each individual component to the value. So I want to be able to do something like that, if you know what I'm talking about. I want to be able to do something like that. So that would be nice. That would be actually super nice. So RGB, of course, has to be vector 3. Right, so it's a vector 3. Okay, so let me see. I'm gonna try to just compile this thing and see if it will break in that specific place. For n. Okay, so that's really strange. Cannot generate code for. This is the most cryptic error message I've ever seen. Okay, so can we just do something like this? I want to comment out everything in here, and we're going to have just a main thing. Right, that doesn't do anything like discard. Right, it discards everything. All right, cannot generate 25. All right. So it's probably not how it works. Where is that thingy that we used? I'm probably using the syntax incorrectly. Nim linear algebra. Yeah, there we go. I think that's what it is. So let's take a look at this thing, and private types. There were types in here. Well, it should work, right? But it doesn't. It just says that you cannot generate this kind of stuff. It is what it is, and it isn't. So maybe you have to. No, arrays doesn't have to be separated like that. And yep. And if I comment it out, right, is it gonna work? It is working. So if I try to do it like that, it's just, maybe this is because I have to do it like this, -1. Don't tell me that I have to do it like that. Seriously? Really? You can do this kind of stuff in for loops to indicate that you don't want to iterate the last one, but you can't do the same in arrays because for whatever reason? Really? Really? I'm so disappointed. Holy freaking shit, this is so bad. This is why I don't take this language seriously. Like, can you be consistent at least? Like, holy fuck. Oh my god. Seriously? It's just like I can't take it seriously. It's a toy language. It's a pretty cool toy language, not gonna lie. Right, but it's just like, holy shit. It couldn't work. Right. Yeah, it cannot generate the code, you see? It couldn't generate the code. All right, so I'm telling you, it's a toy language, literally. So here's the thing. Can we? I really want to be able to do it like that. So I'm iterating each individual component of the result by a reference, and I set it to the value. I want to be able to do it like that. I wonder if it will work. Let's see. It probably won't work, but okay, so it does work. Okay, that's actually pretty cool. Can I now test if it's going to work? Right, so essentially echo vec 69, just 69, and I'm going to say, okay, vector 2. Is it going to be able to print me this thing? Okay. So template generic instantiation here cannot be assigned to, okay. Oh, okay, because it was never instantiated. Since it was never instantiated, it never worked, essentially. All right, so let me see. So for loop, I need basically all of the possible examples of for loop. All of the possible examples of for loop. So for statement, so you can count it like that. It doesn't have enough example. It's an interesting language, but it doesn't have enough examples. Right, so we can iterate it like that. So this is the index, this is the item, scope, and I suppose that is it. Right, for loop by reference. And I'm pretty, it always redirects to this useless tutorial, right? Oh my god, it's just like always like that. Okay. Yeah. Somebody gets it. Somebody gets it. I want to do it like that. How do you do that? Okay. But it seems like expression element for loop cannot be assigned to the original. Should be read-only. It should be readable. Okay. Okay, this is a field. Okay, so I'm thinking I'm wasting too much time on this stuff. So we're gonna be doing something like n less than n, and then the result is essentially gonna be I. So there we go. I'm not gonna even bother to spend too much time on this kind of stuff. All right, so template undeclared identifier I. So this is gonna be I. All right. Okay, there we go. So it actually generated. So, and if I want a vector of like 3, it's also going to work for that as well, hopefully. Yeah, there we go. So it seems to be working. So now we have vectors and shit. So here we're going to have plus, and the plus is effectively like this, right? So result I is equal A, I plus BI. There we go. So the cool part now is that we can simply copy-paste this entire process for pluses, minuses, multiplication, and division. Right, so there we go. So we're gonna have these things. And then I can say that RGB is this stuff, and interestingly, okay, so let's actually try to compile stripes. I don't think it's gonna work really well, but we can try. So type vec2 is basically vec2, right? So we have a bunch of aliases for this kind of stuff. Right, so let's see. So 44, yeah, we don't have this kind of stuff anymore, so let me do this kind of thing, right? Boom, boom, boom. That's precisely why I wanted to do that. And by the way, since we have sort of aliases for this thing, I can say U, right, and this one can be V, UV coordinates, so I can refer however I want with them. All right, type mismatch 44. Okay, and of course this entire thing has to be an array, if I understand correctly, right? So it has to be an array. Is it gonna work? And it worked, in fact. So we compiled this striped thing. So this is RGB, right? So this is RGB, so this is a vec2. I probably have to do something like vec. I wonder if it will infer the type in this specific case. I wonder if it will. And we also want to have a length, right? So let's actually implement length. So length is going to accept the static in here, right? So then a vector n, and we'll return a float, right? So, and in here, essentially what we're doing, we're iterating less than n, right? And the result is effectively plus AI, right? And then is going to be equal to the square root of this entire thing, the square root. There we go. So that way I can just quickly take the length and okay, so that's cool. All right, let's see if it compiles. So 53, it doesn't like that. What does it say? Cannot instantiate n. So that means it needs to know precisely the type of this thing. Can I say 2? And I can. Okay, so I would expect this entire thing to actually infer the generic. It would be kind of cool, right? So it knows the n from UV. It could infer that it also has to be 2, but it couldn't because, well, yeah. It is what it is, and it isn't what it isn't. Is it not? I think it is. Anyway. Cool. So now, what else do we have in here? So we're going to compile it like that. So this is going to be RGB. So this is a UV. And that should be it, if I understand correctly, right? So let's see. Is it gonna work? Okay, 74. Wang, because we don't have Wang files, so let's actually put Japan in here, right? So this is gonna be Japan. Okay, 74. So are you telling me that you cannot destructurize arrays? Is that what you're trying to tell me, my friend? I can't destructurize arrays? Or do I have to do that in a very specific way? Oof, 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 oof. So this is a pixel, right? So we have to do pixel this, right? And then pixel like that, and this is gonna be something like this. We finally make it compile. All right. So finally, we have generic vectors. It was hard. The language didn't help, but we managed to have like generic vectors and whatnot. So, and the thing I want to be able to do, I want to be able to have like max function in here, right? So n static int, and it takes a and b vector n, and basically finds the maximum like component-wise, right? So it finds the maximum component-wise between these entire things. So I in 0 less than n, result I. So can I just put maximum AI BI? So hopefully that will work. We'll see how it goes. Yep. And there we go. So, but we never actually instantiated that generic thing, so maybe it doesn't really matter. So just to actually demonstrate, look what's gonna happen if we replace. I think we need to query replace with the regular expressions, and I'm going to be replacing this thing specifically with just int. Didn't really work that well. I think I have to do it like this. Static. I think it became much more readable. At least if I separate this thing like that. Okay, so maybe if I could do this kind of stuff. Like a single static makes it so noisy for no apparent reason whatsoever, and it just like pisses me off. Why did you have to make it so noisy? Like I don't know, boys and girls. Okay. So query replace. I think this is what we have to do. Yeah, there we go. So let's go back. And instantly it's just like too noisy. Could have been way simpler in my opinion. So how is it going, everyone? Do you guys enjoy NIM so far? Is that a cool language? What do you guys think? Java programming says about noisiness in function declaration. To be fair, Java is not that noisy because it's just a sequence of words, of English words, right? So it doesn't have like, you know, a lot of special characters or anything like that. I would say the noisiness of Java, it's as noisy as Ada, for instance, and it's like words. But here we have like a special characters and stuff like that. Yeah, it's just, what the fuck. Have you ever used Pascal? Any thoughts about it? I never used Pascal. What is it? Never heard of it. Okay. So, we've got that. Zojin, have you used C? I never heard of it. What is it? What is C? I only know NIM. Alright, so what I want you to do in here. So we have a maximum in here and stuff like that. So here we have a bunch of centers, right? We have a bunch of centers. Here is the caller. And the final thing is going to be basically... Oh, in here I can... Yeah, we have a result variable. So that means I can do just result. Right. Result equal maximum between result and t. And I think that will just work fine. Alright, so what do we got? And it didn't compile. Okay, cool. Type mismatch. Got this thing, but expected... Oh, Float 64. So it's happened in 72. I see. I see that. Yeah, I see that. Your daddy give you good advice. I don't quite understand. So we have a C. Oh yeah, because this is supposed to be an array. Sure. This is supposed to be an array. Cool. We have a sequence of these things. Cool. Almost. We're almost there. So we have a maximum got RGB between. I see. Yeah, I see that. I see that. Cool. So can I actually put this thing like in line now? Jiang subscribed at tier 2, holy shit, for 25 months. Holy fuck, thank you so much, Ji, for more than 2 years of tier 2 subscription. Holy shit. Thank you. And welcome to our epic Nim clap. I don't know for how long you've been watching, but we have a Japan flag in here. So let me actually see. So yeah, there we go. We generated a Japan flag, but on CPU, without using any third-party dependencies or anything like that, like pixel by pixel. Right. We're trying to sort of like emulate fragment shaders, right? So essentially, we're iterating from 0 to height and from 0 to width. We're interpolating this entire thing, and we're passing the interpolated things into a pure function, which basically calculates this entire thing. So we're trying to do the sort of like a fragment style stuff. So I still haven't changed my bulb, by the way. You can see how dark it is in my room right now. It is literally dark. So yeah, weirdest features of New Year. I really like that. So I really like to observe how it confuses people in the chat. Like people ask, "What the fuck is right?" So to make it even more confusing. Oh shit! I can't do it like that. So I can probably do it like that and even like that. So let's make it even more confusing. Yep. So, and we can even put it like that. So maybe I can, yeah, perfect. So, and that will work actually. That will actually work. Yep. It's not very smart of a language to do. So it's supposed to be case, not even case insensitive, style insensitive. That's what it's supposed to be. It's a style insensitive language. You can use snake case, you can use camel case. You see, the possibilities are limited. It's such a useful language, it's beautiful. It allows you to do whatever you want. It's style insensitive. Beautiful idea, I absolutely love it. Anyway. But not Pascal case, by the way. Yeah, you cannot do Pascal case because the first character means that it's a type, so you can't use that. That will not compile. Well, it's style insensitive unless you're trying to do a Pascal style. In that case, fuck it, you cannot do that. Sorry. I will never understand it. So to be fair, I personally keep thinking about this feature over and over again for several years already, and I just can't justify it for myself. Like I just cannot do that, and I'm constantly being critical of myself, always, and I just cannot justify it. Like I don't see the point of this thing, except pretty words like you can program in any style you want, but in reality, like nobody cares really. It's just like a really weird thing. I don't know. Maybe I'll never understand that. I'm not a really smart person, unfortunately. Anyways. So we're trying to generate Wang tiles, right? I hope I pronounced their name correctly, though. Wang tiles. So we need to put Wang in here. Right, so this is going to be Wang. Why I keep typing want? My fingers actually have like a memory to type want instead of Wang for some reason. I don't know why. All right, so there we go. So that seems to be working, and okay. Generated something. We generated something, which is cool, I suppose. So we have two circles now. Wang tiles. Well, yeah, but Wang is, as far as I know, it's like a actual name of the person who proposed them. So on top of that, I also want to keep track of the colors, right? So here we can essentially have. So this is the center, right? So this is the center, and here we can have a color. So the first color is red, right? So, and the second thing in here, this one, let's say that it's going to be green, right? Like this. Can I now? Apparently I cannot. But we can probably have something like sides. And can I now put it like that? Okay, so this one is going to be a center, maybe position and the color in sides, right? And then, so we take the position, right? So that gives us this thing. Right, and we want to multiply this thing by a color. But the color is a vector, three-dimensional vector, so that means we need to construct a vector out of the scalar in here, and that will give us the new color. Right, so okay, that looks cool. So this is basically the fragment shader. Let's see if it's gonna work. It does not work because it expects some. Okay. Oh, okay, that makes sense. Maybe that's why it couldn't align everything. No, this is not why. Yeah, Emacs is incapable of actually properly aligning this thing in here for some reason. I don't know. 73. Yeah, sure. And declared identifier side. S. I forgot S. I'm sorry. You never forget S. Okay, that's cool. So if I try to run this entire thing, there we go. So we have two circles of a different color, right? That's pretty poug, not gonna lie. So let's add another circle on the side, right? So somewhere at the right. The right position, in terms of X, I think it's 1, right? I think it's 1, and in terms of Y, it's half, right? And let's also make it blue. And let's see how it's gonna look like. Right, we always like try to take the maximum component-wise, so that means in a place where these things intersect, we're gonna see a really weird, let's say color blending, I think. I think this is what we're gonna see. So let's go. And it didn't compile. Okay, so I wonder why. Because I'm a dummy. Okay, that explains everything. All right, a boom, and that is actually pretty cool. Smick? No? It's actually no. It's actually. Oh shit. Oh yeah, it's a proper blending, isn't it? This is how they blend, aren't they? When you combine red and blue, you have magenta. Yeah, so then now they're blending properly. So the thing we're trying to generate in here, by the way, we're trying to generate Wang tiles for two colors. Well, we have more colors in here, but then we're gonna change the generator to have two colors in there. Yeah. Okay, so let's actually add the second one, right? Let's add this second one. So the fourth one, I mean, I'm sorry. So the left one, in terms of X, is going to be 0, in terms of Y, is going to be that, and we're going to put a yellow in there, right? So this is going to be the yellow. And now we have 4 sides in here. Kind of confused why it blends, because the way we blend colors is that, look, we just find each pixel for each circle, right? And if we have 2 pixels, right, so here's the RGB of one RGB1, RGB1. Let's actually use the colors in this case. And this is another RGB. So the final color, when you mix those things in, is going to be maximum. I don't know how to show that. Maximum between that color, right, and that color, right, and all of that component-wise, RGB, right. So that's how we combine them. So, all right, let's go. Did it ever compile all of that? Maybe it did not. All right, and that was actually kind of weird. Why didn't it blend it properly? But yeah. Okay, so I suppose it turned out to be like a maximum for all of them. Yeah, that's really funny. So yes, could I freaking do so? When they overlap, maybe we can just add them together. I'm not sure what's going to be adding them together, how adding them together will help. So we can try to also reduce the size of the radius. Right, so the radius right now is 1/2. We're going to do something like this. I'm also a little bit tired, as you can see. Yeah. Okay, this one is interesting. That's already could be used as Wang tiles, if you ask me. So that's already pretty cool. Okay, and we can turn them into gradients at some point. Oh shit, that was weird. Okay, 25. Let's actually make 30. Okay, something like that. So after that, we can probably WTF? What are you talking about? Is there something unclear? Or what? I understand. It's just like they started to, you know, overflow or something. I think I want them to barely touch each other, you know? I want them to barely touch each other so they don't... Yeah, something like that. I think this is actually more or less good. Yeah. It will be also kind of cool. Oh, you know, have you guys heard about metaballs? Have you guys heard about metaballs? Metaballs. I never actually tried them, but I want to try them. Yeah, this shit. We could actually make them blend with each other like metaballs or something. That would be actually sick. That would be really, really fucking sick, mate. It's like a ball sack. Yeah. Yeah, I see that. Ugh. By the way, so I think I need to put that in the description. So where is my description? Description, metaballs. And of course, for people who's brave enough to watch those in live, I'm gonna put this thing in the chat. I'm already super tired. Holy fuck, I'm tired. So I think I'm not gonna go crazy on this thing. I think I'm not gonna go super crazy on this thing. And I'm going to simply add the gradient, right? But having metaballs would be even cooler. I think having metaballs would be way cooler. So what we're doing here is essentially we check if this thing is greater or less than radius, but we can use that closeness to the radius as a way to interpolate and make them fade away. You know what I'm talking about? You know? Right, so that means we can just grab this length, divide it by the radius, and I suppose we also want to clamp it, because the bigger it is, the closer it's going to be to 1, so that means we'll have to take a minimum between that and 1, but we also want to invert this entire thing, so we'll have to sort of do 1 minus this entire thing. So that gives us that, and I think this is what I want to call t. So then I'm gonna take this t, turn it into a vector, multiply by the expected color, and put it in here. So that's what I want to try to do. So I think that will create some sort of a gradient in there, I think. Let's see, and boom, there we go. That was easy. So yeah. What if we'll make them actually intersect? So if it's gonna be like a half. Right. Okay. And boom. That is already freaking interesting. This is the hydrogen atom. So that's what it is. Yes, it's a hydrogen atom. Have you seen those? That's actually pretty cool. Or something. It's like sort of like a you know, atom orbitals or electron orbitals or something like that. Electron orbitals. That's what it looks like, at least. Is there something atomic orbitals? Yeah, something like this. I was thinking about this kind of stuff. Yeah. So that's what it is. All right. Is it in excited state? I don't know. Maybe it is. We can make it maybe even bigger. So let's actually say 60. So they intersect even more, hopefully. Right. And at some point, it doesn't really make any sense anymore, I think. Right, at some point, it's just like all blurred together. The cool thing, by the way, boys and girls, is that we're doing all of that on CPU, right? So without any shaders, like if you want to just play with ideas for particular patterns, right? So you have an idea on a particular pattern that you want to do, you don't really need any GLSL. You don't need to set up anything. You can just like straight up try to do that on a CPU. And the only thing that is required to do in here, I think, is essentially just iterate through each individual pixel, interpolate the coordinates of the pixel to like through 0 and 1, and pass them to your fragment shader function, get the color and put the color in there. And you can save that into the ppm format, specifically p6, right? So Google up like ppm image p6. Right, I think this is the most like useful format in my opinion, pp61. ppm, yes, it's a very small m. All right. Cool. I think I want to actually change the way we blend things, if you know what I'm talking about. How can we blend things? Can we just multiply them together? Okay. The thing I'm gonna try, we're gonna just multiply them. No. So the original thing is black, right? The original thing is black. That means if we try to multiply these things together, it's not really gonna work well. But what if we set this entire thing to white, right? So this is the white, and now we're simply multiplying this entire stuff like that. So is it gonna produce a better and more interesting blending? Probably not. So what the hell is going on? Okay, I forgot the parentheses. So what the hell are you? Oh shit, these operators are separate operators. Yikes. Okay, so we'll have to do that, I suppose. I don't want to do that, but we'll have to do that. Okay. I mean, we can specifically do that operator, if you know what I'm talking about. Well, I mean, it's like in C++, so what did you expect? It's like in C++. Proc. So in here, we'll have to accept this entire thing. Hello, Nails Surges, welcome, how are you doing? So, and I suppose, according to the error, first thing has to be a variable, right? So x, a, var, vec n, and this is going to be b vec n. And does it return anything? I think it doesn't return anything. Okay, so we can just do that. And I wonder if I can do simply a multiply b. I think I should be able to do this kind of stuff. Right. And it didn't work. So what I'm thinking is that we can do plus, but if we're gonna do plus, we need to be able to clamp this shit, if you know what I'm talking about. Is that sufficient enough? Hopefully. Anything for you, free foo, of course. Okay, so we can actually try to clamp this thing. Yeah, we do max. Okay, so we're gonna do plus, right? So this is plus, and this is gonna be a minimum, rather, between that and vec3. Vec3 1. There we go. So, and that means I will have to implement the min. So we already have max, let's implement min. And you know how we're gonna implement min? Well, query replace, max, min, boom, easy. So the most reusable code is the one that you can copy paste, right? It's not the one with a lot of generics and stuff like that. It's the one that you can copy paste. Easy, easy peasy, lemon squeezy. Okay, and that didn't fucking work. Because they all overflew. Oh, I know why, because we set the color to be white, so if I remove this thing, it should work now. Alright, so that's a little bit better. That is interesting though. So what if we have more interesting colors? So this is a yellow, this is that, and then something like this. This, and yeah. So let's take a look. Okay. So we can now try to use that as the Wang tiles, probably. I want to actually these things to somehow cover the corners, but I'm not sure if it's going to work really well. Right. So let me try to do the radius a little bit bigger. You know what? I think my problem with this thing is that it starts to fade away right from the center. Right. I want to have something like a rim. Right. So you have the circle, and within the circle, this is horrible. You have the circle, and within the circle, like I draw that smoothly myself. This is completely solid color. Right, this is a completely solid color, and it only starts to fade away like from here, you know, around here. So that's what I want to have. So that means, oh fuck, I'm tired. I'm super tired, super tired. So maybe I'm not gonna do that. One thing I can do now, I think I want to make a small break. So 5 minutes. Yep. So I want to make a cup of tea, right? And yep. So let's continue. So let's quickly get this to some sort of like more or less finished state for this episode of the Wang tiles. I suppose I'm gonna do a second one because we didn't even get into the actual engine that generates the grid of tiles, right? Because that could be an episode by itself, right? Because you'll have to take the masks of nearby tiles, and you will have to figure out the mask of all the allowed tiles that can go in there. So it's an algorithm on its own that may require its own episode. So it's actually the task is bigger than I anticipated. As usual, programmers are really bad at estimating things. In my opinion, it's not the programmers bad at estimated things. It's just the things the programmers work with are really bad at being estimated. You know what I'm talking about? So the nature of the problems we're solving, they cannot be really estimated properly, right? So because quite often we don't even know what we need to do to solve the problem. So we need to start solving the problem to at least understand the problem a little bit better, and then we can estimate it to some degree. Right, so the problem we're solving are not really great at being estimated. It's not the programmer's fault. It's the nature of the problems we're solving. Agile estimation, they don't make any sense. Agile itself is a huge scam, so I don't really buy it. Right. All right. Okay. So let me see. What I want to actually have in here is, on top of accepting UV, I also want to accept a mask that represents the sides, right? So essentially, we need to decide how we're going to represent the sides, right? So we have a quad, we have a tile, right? 1, 2, 3. Scam master. Does your team have a scam master already? Or any scam meetings? Anyway, so there we go. This one is the top, right? So this is the top, and we have bottom. Here we have left, if I understand shit correctly, right? I can put left in here, and here we have right. There we go. So here is our tile. So we need to store the thing in a particular order. So let's actually store them. Oh, BLT. Right. Let's store them clockwise, starting from bottom. BLTR. Right. So like a sandwich, right? Like a sandwich. Bacon, latest, tomato, R. What could be R? So what kind of sandwich is this? What is R? Radish in a sandwich? Yikes. Ranch. Okay, so ranch actually sounds good. Like a ram ranch? Got you hyper? Yes. Okay. So BLTR. So that's the sandwich we're gonna have in here. Cool. And yeah, so basically bits in this specific mask represent the color. So since we're doing Wang tiles with 2 colors, 0 is going to be, let's say, maybe yellow color, and 1 is going to be maybe, I don't know, magenta color, right? So, and based on this mask, the Wang thing should generate things accordingly, right? So maybe we're gonna actually accept it like this. I really want to actually accept it as BLTR. I think it's a pretty good name for a variable, right? So and we're gonna have, can we have uint8? Nim uint8. Let me see. Is that a thing? So there's a system module. uint8. Okay, we do have uint8. Would you look at that? I clicked on it. There it is. Unsigned 8-bit. So let's take a look at the source. Okay. It's a compiler magic. I really like this directive. Oh, by the way, this is a very dangerous page. You know why? Because it redirects you to GitHub, edit, and edit automatically forks the repo under your name. So if you try to click edit, that will automatically clone, like fork, repo into your account. So I remember clicking on this thing once and it's just like, holy fucking shit, it started to do shit. And like, oh my god, oh fuck, ah! And yeah, it's just like, why? Why would you do it like that? This is so... First of all, why GitHub would implement this stupid edit feature that forks and stuff like that? And second of all, why would you integrate with that? It's just like... yeah. So, because I actually did it once and it was like, holy fuck, bruh, why? Okay, so BLTR. So we accept BLTR in here. And this is right. So I suppose we'll have to store these side points somewhere, right? So, since it's a BLTR, it actually also depends on how we iterate through this entire thing. If we're gonna be iterating it starting from the right side, the bit masks are way easier to iterate starting from the right? So we have something like this. This is not a bit mask. Basically, you can divide by 2, right? If you have x, right, and you divide it by 2, you will basically shift everything, but you can always just shift it like that, right? So that will give you this thing without this thing, and at any point you can just do something like this, and that will give you a bit from here, right? That way you have two operations, basically take the top of the stack of the bits and pop it out. Right, so, and because all the top is the right one, it is easier to iterate starting from the right. So it would be way easier to keep the sides RTLB, if you know what I'm talking about. RTLB, so this is going to be sides, and what we're going to have, so the right one, RTLB. So the right one in terms of, can I do it like that? RTLB. So, and in here, the right one, in terms of X, it's 1, and in terms of Y, it's half. Okay, cool. The top one, in terms of X, is half, but in terms of Y, it's 0. Makes sense. Left one, in terms of X, it is 0, and in terms of Y, it is half. I can see that. Bottom, in terms of X, it's half. In terms of Y, it's 1. Okay, I think I didn't make any mistakes in here. Here are the sides that we need to iterate in here. So the radius stays the same, and I wonder if I can make this entire thing const. Maybe not, I don't know, doesn't matter. And it also greatly depends, yeah, we also need to keep track of the color, right? So here's the sides, and now we also have the colors. And the color, I think I'm gonna make it some sort of an array. So the first color at 0 is going to be yellow, right? So we're gonna keep it yellow. So this one is 0. And this one is probably going to be magenta. So this is not yellow, by the way. This is yellow. Magenta is something like this. So this is going to be 1. So if your color is 0, this is going to be your color. If your color is 1, this is going to be your color. All right, so we have all of these things that are necessary. So after that, we are starting to iterate these sides, right? So, and that gives us the positions. Here are the positions. Here is the position, so I calculate this thing, and now I need to grab the color, but the color is essentially, the color is colors, BLTR, and I want to do mod 1, but I'm not sure if it's, I think this is how we do that. I think it recognizes that you're doing that with numbers, and it becomes like a bit operations or something like that. So that way it kind of works. Then we are combining all of that, right? So this is combining, and then I can do BLTR, BLTR shift. We need to shift to the right, right? Shift right one. GNU Pro, I would kindly ask you to stop backseating. It really stresses me out. Because you've been doing that the whole stream, I'm trying to like politely ignore you to sort of like let you know that, you know, like I don't really need your help, but you don't seem to be understanding that. So I'm telling you directly now, please stop backseating. You're not helping. Thank you very much. Okay, so this is how it's gonna go. Okay. All right, so there we go. Okay, BLTR cannot be assigned to. All right, this one is interesting. So these things are constant, right? So these things are constant. So maybe because of that, I want to actually do something like var mask BLTR, and that's what we're going to be doing in here. Query replace BLTR mask. Okay. All right. So okay, this is actually very interesting. Type mismatch got array 01. So let me. Oh yeah. Okay. So that makes sense. 116. Okay. Now. We can try to put different masks in there and see how they will work. I can put 0 in here, and that will color everything with the same color, right? So that's what it will do. So let's see how it goes. Okay. And if I refresh this entire thing, it didn't do anything surprisingly. Okay. Let me see. That's really sus. Is that because... Okay, it still uses the same stuff, and I don't really understand why. Because we're using sites. Wait. Okay. We're only supposed to have yellow and magenta, right? So that's the only thing we're supposed to have in here. Only yellow and magenta, but it looks like it completely ignored this thing. Here's the colors, here's that. If I change it to Japan, right, is it gonna do a different thing? Oh, okay. Oh yeah, because Japan doesn't accept this thing. Oh, okay, so it doesn't actually resave it or anything like that. So if I remove this entire thing and it recompiles the I'm an idiot. So you're supposed to run this thing. Okay, I can see it now. There we go. So here's the Japan flag, and right, so this one is going to be Wang, and I'm going to put 0 in here. Right, so here's the 0. All right, so we're gonna do that, and here is basically the thing. Okay, so if I have 1, so one of the sides will be of the magenta color, and let's see how it's gonna look like. There we go. So here's one of the sides. If it's gonna be 2, right, so the other side is gonna be of the magenta color. There we go. So this is the other side, and 3 is actually 2 bits now, right? So it's gonna mean that both of these sides are gonna be magenta color, right? So, and you can basically go and generate all of the possible tiles for the Wang tile set, all 16 of them. So let me actually try to do that. So something like save Wang tile, right? So here we're gonna be accepting, I suppose, the BLTR, which is uint8t. It's not t, right? It has to be this thing. And here we're gonna have file path, and it's gonna be a string, right? And I suppose I'm gonna be copying this entire thing in here, and we're going to be sending mask like this, right? And we're going to be using file path like this. There we go. And let's try to generate the like the whole Wang tile set and save it to the file system, right? So we're gonna be iterating starting from let's call BLTR in 0 less than 16, right? And I'm gonna do save. And of course, I define it as a snake case, and I'm gonna do something like this, save like this BLTR, and it's gonna work, right? Because you know, nim. All right, so this is gonna be FMT, and in here we're gonna have tile, right? BLTR, PPM, right? There we go, and that should generate us the full Wang tile set. All right, so maybe I can even save things like a file path in here. Here's the file path, and then we can echo generated file path like this. And let's see what's going to happen in here. There we go. So let's run this entire thing. And there's a problem in here. So what's up with that? Expression expected but found key. Oh, okay, so this has to be like this. Are you gonna work now, hopefully? All right. So type mismatch, int string uint. BLTR is a type of int. I wonder if you can have int literals in here. So I think the easiest way to do it right now is gonna be something like this. Right, so it's probably there is a better way to do that, but I don't care about it right now. So there we go, we're generating each tile. So it actually takes some time to generate all of them. Okay. So, and that's why you probably want to use OpenGL, right? You want to do that on GPU. Okay, so here is the bunch of tiles. And I think I want to actually generate them with the leading 0. And I wonder how you can do that. So let me see, let me take a look at the string format and just see how you generate this thing. Very nice, yeah. So it's definitely an improvement over the C compilers, of course. So str format, what's the format in here? Leading, so there should be some sort of a padding. Okay, formatting strings. Okay, you can, yeah, you can pad, and I suppose you can also pad the numbers with 0. Yeah, you can put 0, 3. Okay, that's perfect actually. So I can put something like 0, 2 in here, right? And first of all, let me try to remove all of the ppm things, right? So here are all of the ppms, and let me try to recompile the entire stuff. So there we go. So now we have a leading 0. Left pad, by the way. So left pad didn't even require a third-party dependency for a left pad. I wonder if we can generate more like faster code for this kind of stuff. Okay, so I'm gonna do the but I'm gonna do that for each individual tile. There we go. So here are all the tiles. This is the entire tile set. There we go. The entire tile set. And theoretically, you can now generate a grid out of these tiles. Optimization flags, maybe. So can I do something like de-release? Is that a thing you can do? Okay, so... Oh, okay, so that helped. All right. So that was faster. I suppose it just passed 03 to the GCC compiler, right? So that's what it did. There we go. So here is the full Wang tile set. So the next thing I would like to do is probably make an engine, right, that generates a grid of these kind of tiles, right? But unfortunately, we already spent too much time working on this stuff, so I don't think we have too much time. So also, the tiles themselves are huge. We can probably want to have like 64 by 64, so let's do it like this. So I think this is going to be, yeah, it's instantly generated all the entire tile set. Right, so and if I try to take a look at that, so this is the whole tile set. That's pretty cool. Did you get a new camera? Looking nice. Or did you switch the places? I think the lighting has changed. Let me take a look. Do I look better now? I don't know. Hard to tell. So, all right. Let me actually git ignore all of the ppm files. Right. And do we have... Yeah, it would be actually better to do something like this and de-release as well. All right. Okay. So let's do a committee. Generate the full Wang tile set, and I'm gonna push that right into the repo. I wonder if there is like super easy way for me to just place all of these tiles together. So 16, it's basically 4 by 4, right? So it's essentially 4 by 4. Can I generate at least some sort of grid? I think it's gonna take too much time. All right, so I'm not gonna do that. All right, so this is what we managed to implement today, right? We implemented a simple Wang tile set generator. 256. And let's take a look at these Wang tiles one more time. So here are all of the Wang tiles. So, and unfortunately we didn't have time to implement the the thing that generates a random grid, but we're gonna do that next time. You can find the source code of this project in here in the chat if you're brave enough to watch Zozin live, and if you are watching in the on the YouTube, right? So you can find all of this stuff in the description. So maybe I'm gonna actually put a couple of to-dos. So wait a second. So where is the Wang tile thingy? So here is that. More Wang tile ideas. Right, so we need to have more Wang tile ideas. For instance, metaballs. So, and if we're going to have some other ideas, we're gonna place them there as well. Right, so I just don't want to forget about the idea for metaballs. Right, so in here is basically the description of how we represent the tiles and whatnot. So I'm not sure if this thing is really that necessary, but the thing that is necessary here is something like this. Okay. So 0, 1, 2, etc. So then 1, 1, 1 is 15, if I understand correctly. Might as well also pad the entire thing with 0. All right. Make the tiles bigger, then add more ideas for Wang tiles, right? And update tile bit mask description. There we go. And I'm gonna push that right into the repo. All right, that's it for today. Thanks everyone who's watching right now. I really appreciate it. I hope today's stream was interesting. So we switched up the language a little bit. So maybe Nim was interesting for somebody. It's actually a pretty cool language, but it's been like kind of stagnating over the past, and it's not really. It could be a really good candidate to kill C, but I suppose a lot of developers dragging this language to different like directions, so it's kind of not clear what kind of language it wants to be. It wants to be like a low-level language or web language because it compiles to C, to JavaScript or something like that. But maybe these days like web is the low-level thing, like browser is the operating system you develop for, or something like that. I don't know. Like the premise of this language is actually quite cool, but it feels like it under-delivered on that premise. I don't know, that's what it feels like. Well, yeah, and another thing, GC language is not a C killer, but again, you can disable the GC. All of them always say you can always disable GC, but yet all of the libraries are designed to have GC and have no mechanism for you to manage the memory, so they become useless. So it's like, it's like pointless. Nobody's disabling GC because of that. This is, I don't know. So, and you end up like calling GC menu or something like that. It's just like, it's a mess. It's a mess. Anyway, so thanks everyone who's watching right now. Really appreciate it. Have a good one, and I see you all next time on the second episode of Wang tile generation series. I have no goal for this thing. I'm just exploring the idea space of this thing, and I see what I can do with it. See you all next time, and yeah, I gotta go. Love you all. Mwah.